Hey there, Geometry. It's Mr. Lamb coming to you with the Unit 2 test review. This is the key. I'm going to do 4 different videos. I'll do each page on each video. So let's take a look at page 1. Question 1, 2, and 3 say to classify the triangle by its sides and then by its angles. So I'm going to first just pay attention to the sides. Let's talk about just the sides for these 3 first. So in question number 1, you'll see these little marks on the edges showing me that all 3 sides are the same. That makes this an equilateral. E-Q-U-I, lateral. You see the word lateral, you're always going to think sides. So that is equilateral. And number 2, I see the left side here has 1 mark. The right side has 2 marks, meaning they're different. And the bottom side has 3 marks, meaning it's also different. So all 3 sides are of different lengths. We call that scalene. And then number 3, it says in triangle RJH. RJ equals 6, RH equals 6 radical 2, so they are different. And JH equals 6. So I have 2 sides the same. That is called isosceles. And now I'm going to take a look at the angles. So now I want to classify by angles. So in question number 1, all 3 angles are of x degrees. They are all the same. So this is equilateral, or I'm sorry, equiangular. Those of you that know a little bit about equilateral triangles, all equilateral triangles are also equiangular. That's always true. And actually, all of those degree measures are always 60 degrees. That may come in handy later on. Question number 2, there is 1 angle up here. 2 of them are going to be acute. One of them is 100 degrees. It is obtuse. That makes the triangle obtuse. And then number 3, 2 of them, R and H, are acute, and the third one is 90, so that makes this a right triangle. So what type of a triangle is number 1? It is an equilateral and equiangular. Number 2 is a scalene obtuse triangle, and number 3 is a isosceles right triangle. For number 4, 5, 6, well, the directions say for 6 through 8, find the value of x, and that should say for 4, 5, and 6, find the value of x. So question number 4, I have 3 angles in a triangle, and I know that they should add up to 180 degrees. So I will go 2x plus 2. That's this angle right here. Plus 2x plus 2. This angle over here. Plus 3x plus 1, which is this angle down here. I'm going to add those 3 angles up. So 2x, 2x, and 3x is, that's 4 and 3 is 7x. 2 and 2 and 1 is 5. So when I add those 3 angles up, they add up to 7x plus 5. And I know that 7x plus 5 has to equal 180 degrees. So let me move this up. So if I have to find x, I just use 7x plus 5 and I set it equal to 180. So I'll subtract 5 on both sides. So 7x equals 175, and then divide by 7, and x is equal to 25. So that is my value for x. It doesn't say that I have to find out what each one of the angles equal. If you plug 25 in there, I'll tell you right now, it looks like you have 52, 52, and 76 would be those 3 angles for that one. For number 5, this is an exterior angle, so angle BAF. If you look at BAF, it is not inside the triangle, it is outside of the triangle. We call that an exterior angle. So this is exterior. And we know that the exterior angle is equal to the sum of the remote interiors. So this is a remote interior, and this is a remote interior. So 13x minus 3 has to equal the 2 remote interiors added together. So 3x plus 2 plus 55. Let's do a little algebra. So I'll leave the left side alone. 13x minus 3. Let's do some substitution here. Combine the like terms. 3x and 2 and 55 is 57. Add 3 to both sides. So 13x equals 3x plus 60. Subtract 3x on both sides. 10x is 60. Divide by 10. X is equal to 6. So I can plug that in. Angle B then is 20 degrees. And angle BAF would be, what, 75 degrees. 75. Okay. I'm going to try to move this over a little bit just to make some room. Okay. Let's take a look at number 6. Doing the same thing, trying to find x. I'm going to first look at this left triangle over here. I want to use orange. All right, so this left triangle, we'll go brown, that's fine. This left triangle is an isosceles triangle. I know that because of the little red marks on the sides. So because this is an isosceles, base angles are congruent. So if this angle in the bottom left is 68, the angle in the bottom right is 68. Then I know that all triangles have to add up to 180. So 180, if I subtract 68, and then I subtract 68 again, is going to leave me 44 degrees. So 44 degrees is this, not angle 2, but the one to the left of it. This one over here is 44. So that triangle is 68, 68, and 44. Now I'm going to look at the triangle to the right. I don't know what my base angles are. Right? Just because the left triangle has 68 degrees does not mean the right triangle does. But if I look at the top, I see this little red square in the top. It's right here. Look at the arrow. That little red square right there means that that top is 90 degrees. So if I want to know measure of angle 2, I will take my 90 degrees and I will subtract the 44 from it. So that is 46. So angle 2 over here is 46 degrees. And then really, if you want to find the bottom 2 angles, you know they have to be the same because that right triangle is isosceles. So I could do 180 minus 46 and divide by 2, and I would find out that these two are actually 67 apiece. So that's just for those of you that are kind of wondering. You don't need to know those 67s. Here's what I need to know. The measure of angle 2 is 4x minus 2. And 4x minus 2 is equal to, we just said, was 46 degrees. So I'm just going to solve this for x. Add 2 to both sides. 4x is 48. Divide by 4, x is equal to 12. I do not ever, don't just look at the picture and say, well, it looks like that cuts that angle in half, so that's 45 and 45. Because your eyes are not good enough to see a 1 degree difference. All right, I'm going to try to get them close, but never just look at something and assume because it looks like it is. Actually prove it mathematically. All right, and question number 7. We have to find x, y, and z. The figure may not be drawn to scale. Okay, so I'm going to take a look at the left triangle first. That left triangle right there has x in it. I know this. They have to add up to 180. So 60 plus 31 plus x has to equal 180. Get rid of that. All right, 60 and 31 is 91 plus x is 180. Subtract 91 on both sides, and x is 89. So x is 89 degrees. In order to find y, so I'm going to draw this in now. This is now 89. To find y, I see the straight line. I have 89 and y. That's a straight line. Has to add up to 180. So 89 plus y is a straight line. Has to add up to 180. Subtract 89 on both sides, and y is 91. this one over here is 91. And then to find Z, look at the triangle to the right. 3 angles, 25 plus 91 plus Z has to add up to 180. It's a triangle. So that is 116 plus Z is 180. Subtract 116, and you should get 64. So 64. The other option you have is we could have done exterior angles if we wanted to. To find Y, I could have done 60 plus 31 is 91. And to get the Z, I could have done 25 plus Z equals 89. I could have used exterior angles if I wanted to. I just think it's a lot easier if you just deal with triangles adding up to 180. So that is the end of page 1. Tune to the next video to see page 2.